Hello again, it's me. I'm Dr. Derek Keats, former professor of biology, and yes, it's true I'm still here with you, talking about the human endocrine system. And we still have one more to go. This time we'll look at the role of hormones of the gonads. Everyone wants to know about their gonads, not so? So remember that some of the components of the endocrine system are found within the reproductive system, and the ovary, the uterus, the placenta, and the testes all have a role to play in our endocrine systems. Now let's begin our discussion of the endocrine role of the gonads with the hormones that are involved in reproduction. They are estrogen, progesterone, and testosterone. However, also involved are FSH, follicle-stimulating hormone, LH, or luteinizing hormone, and GnRH, or gonadotropin-releasing hormone, sometimes called LHRH, luteinizing hormone-releasing hormone, which is hard to say. So we're going to stick with GnRH. Now, while testosterone, estrogen, and progesterone are all produced by the gonads, GnRH, FSH, and LH are produced elsewhere. Testosterone, estrogen, and progesterone have their effects both in the gonads and elsewhere in the body from the perspective of what we're studying here, but GnRH, FSH, and LH have their most important effects in the gonads. Now, the hypothalamus and the pituitary glands also play a role here, and there are two areas that these hormones play their roles in terms of reproduction: the reproductive maturation and the reproductive cycle. Now let's take the hormones that are produced outside of the gonads first and see what they do and how they affect the gonads themselves. Let's start with the hypothalamus. It releases GnRH, gonadotropin-releasing hormone, which incidentally is synthesized and released from the neurons within the hypothalamus. Now, you don't need to know this, but it's interesting that we have a hormone here that is actually synthesized and released by neurons. So GnRH acts on the pituitary, causing it to release follicle-stimulating hormone, FSH, as well as luteinizing hormone, LH. These hormones have numerous effects within the body, but their primary effects are via other hormones that are produced by the gonads, that is, our testosterone, estrogen, and progesterone. Now let's look at each of those before we look at how they interact. We'll start with estrogen. It's not one compound, but rather a group of steroidal compounds named for their importance in the estrous cycle of humans and other animals. Now, estrogen is usually thought of as the main female sex hormone, although this is perhaps a distorted view, since other hormones also play important roles. Estrogen promotes the development of female secondary sexual characteristics, such as breasts and fat deposits, mainly around the buttocks, hips, and thighs, that give females a distinctive look. Now, estrogen is involved also in regulating the menstrual cycle, and we'll talk a bit about that. It's synthesized mainly in the Graafian or ovarian follicles of the ovary in response to the activity of FSH, or follicle-stimulating hormone. We're going to see this in a bit more detail later. Now let's move on to progesterone. Progesterone is also a steroidal hormone involved in reproduction in humans and other animals. It's also an important female sex hormone. It's involved in the menstrual cycle, in pregnancy, and in embryogenesis. Progesterone is produced in the ovaries by the corpus luteum. Some progesterone is also produced by the adrenal glands and in the placenta during pregnancy. Now, testosterone is also a steroidal hormone, and it belongs to the androgen group in humans and other animals. It's an important male sex hormone, and testosterone plays a key role in the development of male reproductive tissues, such as the testes and the prostate. It also promotes secondary sexual characteristics in males, including increased muscle, increased bone mass, and the growth of body hair. This hormone is secreted primarily by the testes of males, but is also secreted in the ovaries of females. Now, although we refer to these three hormones as if they were only present in one sex or the other, all three hormones are in fact found in both sexes. However, we can look at relative daily production levels to see some differences. Let's take testosterone. Daily production levels are much higher in men than in women. Progesterone, on the other hand, is much higher at daily production levels in women than in men. As is also true of estrogen, much higher daily production levels in women than in men. That's why we often talk about them as if they were female and male hormones, even though they're not exclusive to either sex. Now, the onset of reproductive maturation in humans is referred to as puberty. In females, breasts develop, the pelvic region enlarges to allow for childbirth, and there is the onset of ovulation and menstruation or menses. Secondary sexual characteristics also develop. And this is all under the control, largely, of estrogen. In males, the testicles mature and are able to produce viable sperm. And also secondary sexual characteristics develop, as we have seen in the previous slide. Now, all of this is largely determined by testosterone. Now, let's look at the role of these hormones in the reproductive cycle of female humans, where it is usually referred to as the menstrual cycle. This is the term used to cover the physiological changes that occur in fertile women over the course of a month or so for the purpose of sexual reproduction and fertilization, and is generally divided into three phases: the follicular phase, ovulation, and the luteal phase. Menstrual cycles are counted from the first day of menstrual bleeding, and they usually last for approximately 28 days, although this is not exactly the same in all females. Now, we'll look at this in more detail later. So, now let's look in more detail at the key role of hormones. And to do that, we can take a preliminary look at this cycle. I'm going to populate this diagram first and explain what each piece of the diagram means, so that when we have more information on the diagram, it will be easier for you to understand what this diagram is telling us. Now, the first piece is the number of days, noting that although the cycle is on average about 28 days, the duration varies from woman to woman, as well as during a given woman's lifetime. Here you can see a line running from day 1 to day 28, with a vertical line at day 14, which is approximately the middle of the ovulation time. The follicular phase is indicated in purple, and the luteal phase is indicated in green. I hope that's clear enough. The second piece that we're going to show in this diagram will show a graph of the hormone levels in the body over this 28-day cycle. Now, what I've shown here is just the background. The graphs will come in a bit. This is just so that you understand what the graphs are talking about. And the third piece is what happens in the ovary, the pink ovals in the diagram, one of which is inside of a red box. Here, imagine the ovaries stretched out to cover the time period, to show the key events that happen within the ovary. The next part of our diagram is what happens in the uterus, the uterine cycle, which includes menses, or menstruation, and the proliferation phase and the secretory phase. So that's the uterine cycle. That's what happens inside the uterus. Now this line represents follicle stimulating hormone, FSH, and you can see some changes over time here. And this one, luteinizing hormone, and you can see some very clear changes over time here. And this is the graph for what happens with estrogen. And finally this one for progesterone. And you can see that there are some differences over time in the levels of these hormones. Now let's just add what happens in the follicle of the ovary without saying anything about it for now. But you can see that there are changes happening. And last, let's add the diagrams to illustrate what happens in the uterus at these times over the cycle. Okay, so now what we're going to do is we're going to look at these changes in a bit more detail. So let's start with the beginning of menses. The endometrial lining, that is the lining of the uterus, sheds, which causes the bleeding experience during the menstrual period. The hypothalamus produces gonadotropin-releasing hormone, GnRH, which in turn brings about the release of follicle-stimulating hormone, FSH, from the pituitary gland. FSH causes small follicles to develop inside the ovary. One follicle begins to grow larger and secretes estrogen. This dominant follicle produces a cell, an oocyte, that will become an ovum or an egg. The other follicles atrophy and die. It is the life of this dominant follicle that we'll be following in the diagram. A few days after menstrual bleeding begins, the endometrial lining, indicated by the pink arrow here, begins to rebuild, stimulated by increasing production of estrogen from the follicle cell of the ovary. Discharges of blood slow and stop, and the lining of the uterus thickens. As the middle of the cycle nears, increasing estrogen levels stimulate secretion of more GnRH and luteinizing hormone, LH, from the pituitary gland. LH triggers ovulation, the release of the egg or ovum from the ovary, and stimulates the production of progesterone. In the luteal phase, the ruptured follicle, now called the corpus luteum, begins to produce estrogen and lots of progesterone. The corpus luteum has a primary function of producing this large amounts of progesterone. Now, increasing amounts of estrogen and progesterone cause a decrease in follicle-stimulating hormone and LH, and causes a change in the endometrial lining. The lining becomes thicker and its blood supply increases, preparing the lining to accept an embryo in case fertilization and implantation should occur. If fertilization does not occur, estrogen and progesterone levels fall, the endometrial lining sheds, and bleeding begins again, thus completing the cycle. But what happens if there is a pregnancy? Both estrogen and progesterone have large roles to play. Estrogen is produced first mainly by the ovaries, but later by the placenta as well. Estrogen's role are too many to mention them all here, but here are some. Estrogen produced in the ovaries initially, but later in the placenta during a pregnancy, helps with the growth of the uterus. It maintains the lining of the uterus. It increases blood circulation, and it activates and regulates the production of other hormones. Now, in early pregnancy, estrogen promotes the growth of breast mass and later helps to develop their milk-producing capabilities. Progesterone also plays an important role, and it is produced first mainly by the ovaries and then later by the placenta as well. It is important in breast development, in the functioning of the placenta, and the functioning of the uterus. It reduces contractions of muscles, particularly the smooth muscle of the uterus, allowing the baby to develop in the expanding uterus. Now, we've covered what you need to know about this topic for the South African Grade 12 syllabus, but please check any text or other pages in the e-learning system in case there is other information there that might be useful to you. And if you want to take your learning a little bit further, you can search on Google or another search engine for terms such as estrogen or estrogen without the O, progesterone, testosterone, secondary sexual characteristics, menstrual cycle, or any of the other terms that we've covered in this video. Also, you can look for videos on YouTube. You might find something interesting there. If you do, remember to share it on the wiki. And that's all for now. I'm Derek Keats, and this resource is licensed under a Creative Commons Attribution License. Bye for now.